Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about solar hydrogen panels. So let's dive right into it. Now you have to understand, when we are talking about hydrogen, we are not always talking about something in future, as in like future we're gonna run cars or planes or things of that nature. Remove those puppies, remove that. We still have ludicrously high demand of hydrogen. And I mean seriously, as in from ammonia production now. Like, is ammonia important? If food is important, ammonia is important. Methanol, so many chemical process relies on that. Important puppy. Metals, really important puppy. Production of metals, methanol and basically ammonia consumes hydrogen like there is no tomorrow. And then we come to food industry, and then we also come to semiconductor electronical industry, meaning hydrogen is one of those puppies that we are consuming like there is no tomorrow. So how the heck we are providing that hydrogen at this point in time? Well, we are cheating, quote unquote. We are making hydrogen from CNG, basically compressed natural gas. What does that mean? That simply means we are taking methane and making it marry steam, very high pressure steam, and output is we get hydrogen. Consequence, we still get carbon dioxide. Basically, you quote unquote partially burned the methane, so to say. So you get hydrogen out and carbon monoxide and blah blah blah. You can balance the equation out. But our problem is that even though it's hydrogen, even though you can sell that hydrogen to someone, hey, run this hydrogen in your truck, so to say, outcome would be still you are still releasing CO2. You are releasing actually more CO2 if you were directly using CH4, but it's just out of sight, so people don't worry about it. But reality is we are consuming a lot of hydrogen and we are consuming a lot of methane. So that creates a scenario where we need clean hydrogen. Remove hydrogen from like energy and all that jazz. But from an industrial point of view, a nation consumes hydrogen. So if we can make that puppy clean, where we are like, hey, we no longer have to buy basically methane or it's products from other places, that would be really awesome. So there is a very serious demand in our world where it's like, bro, figure out hydrogen source where we no longer have to create quote unquote dirty hydrogen. So what's our dream? Our dream is basically we want what plants have. What plants have is basically they have two components, and one of those components is that they can take hydrogen basically out of water directly using sunlight. Sunlight is the energy source, and they can take water H2O and get H2 out of it. That's awesome. That's miracles technology. We want that. Now, do we have it? Not really. What we want is what we call photohydrogen. Photohydrogen is something like this. Basically, we send water, we put light, and voila, hydrogen comes out of it. Can we do it? A little bit, yes. If you have a very specific wavelength of ultraviolet, you can cause water molecules to split with very little energy input. You're still putting a lot of energy, but it can be done with photons. You can do it if you have that specific wavelength. Why don't we do it? Energy cost is too stupidly high. Another option is that you put biological enzymes that are responsible for it. Basically, you go inside photosynthesis, you figure out that exact enzyme that is responsible for doing this. Basically, putting sunlight and putting sunlight to work and breaking H2O, you use that enzyme to make this puppy out. Have we done it? Yes, in lab. So this sort of experiment, you will see a lot of it. Is it something that can be done? Yes. Is it something that can be done on a large scale? No. Then we have, this is what we want. At the end of the day, that's our goal is. Our goal is that we have a flask, quote unquote, or some structure where we send water, sunlight falls on it, voila, hydrogen on the other end. That's our hope. We are not there yet, not even close, but that's what we are aiming for. Now, there is another option, which is more brute force option, which is my personal favorite option, is that you burn water. We call it thermolysis. Now, think of it this way. Everything in chemistry is two-way, meaning if it goes this way, it can also go this way. So what does that mean? That simply means if you take hydrogen, you take oxygen, you get them married together, what happens? They make a lot of love and they put a lot of energy out. What is that energy? Heat. What happens if you put a lot of heat into it? Same thing, it splits apart. You undid that reaction. So that we call thermolysis. So there are companies, I have linked the video down below, which made a basically giant solar collector, focused lot of solar energy into one small spot and put water there, and water went boom. And if you are familiar with nuclear power plants, you must have heard that water goes boom in nuclear power plant. It's like, what the hell happened? Well, if you have water at very high temperature and very high pressure, specifically presence of some metal will cause it to literally split into hydrogen and oxygen. And at that point in time, you have a boom material. It goes boom. So that's the whole point of thermolysis. If you have high temperature, and you have basically high temperature plus basically a catalyst, and then you can achieve thermolysis, and you have basically water going in, heat going in, and you have hydrogen and oxygen coming out of it. It can be done. Can it be done on large scale? Companies are trying to achieve it. So far they have not, but it can be done. It can be. Physics is not stopping you. Engineering is like, we are not there yet. It can be done. Let me be very clear. Can this be done? Yes. Can this puppy be done? Yes. Can we do it in large scale? No. At this point in time, when I'm making this 2023. So what is the other option? Well, other option is direct air electrolysis. Can we have us, basically electrolyzer unit that is consuming water and giving out hydrogen and oxygen? Yes. Then why don't we do it? Well, water is expensive and you can't put salty water. Basically, you cannot take, seawater, you put seawater into electrolyzer. That electrolyzer company, be it Siemens, be it ABB, they're gonna find a homing missile and they're gonna launch it up your ass if you did that, because it's gonna corrode instantaneously. So we need distilled water. At that point in time, your hydrogen cost, basically per kilogram of hydrogen cost, goes stupid. That's why we don't do it. So somebody figured out, what if we bypass that stage where we need distilled water? What if we directly extracted water from air? Now, how the heck it can work? Well, thankfully, our atmosphere is made out of air. Air has a lot of components. One of those components, like same way it has oxygen, same way it has carbon dioxide, same way it has nitrogen, it also has water vapor, H2O, in gaseous state. And benefit of this state, it's pure. H2O, that's it, done. There is nothing other than that. Even distilled water have this issue that it may have dissolved gases, and consequences of dissolved gases going to an electrolyzer stack is going to cause erosion, corrosion, things of bad nature that you do not want to happen. But if you are directly sucking up air, all you have is pure H2O. So somebody figured out, why don't directly use that rather than having liquid? What if we directly have a sponge medium, quote unquote, and the sponge medium absorbs basically water vapor, and then we react it. That's it. So we no longer need distilled water, and the output, the gases that's going to come out, be mindful, though, will be very low pressure, like very low pressure, very low pressure. And the sponge is going to act as an impermeable membrane, because you have to understand one aspect. If you have hydrogen and oxygen must be separated. Meaning, if you are putting hydrogen in a tank and let's say it's 90% pure, nobody is going to touch that tank, because that tank is not a tank of fuel. That tank is a tank of boom. It's going to go boom. So fundamentally, whenever you want to store hydrogen, it has to be very high purity, like very high purity, and I mean like 99.99 kind of purity. Otherwise, it's genuinely dangerous. So if you are in a company which are making electrolyzer unit and hydrogen and oxygen coming out in this in one tube, it has to be consumed instantly. It is done in jewelry industry, where they have like water electrolyzer, and then they have hydrogen oxygen flame. It's a very good flame to work with precious metal. So that can be done. But if you directly try to store it, no, that's a rocket boom, and actually more powerful than rocket, because rocket have overflow. Generally they have overflow hydrogen, so it's gonna be far more powerful than that. So this is one thing that you must understand. So impermeability is the core aspect. If you build this sponge system and somehow your oxygen is contaminating the hydrogen part, it's useless. You throw it away, or you use the hydrogen instantaneously. Basically, if you are using it as to heat your home, you have to burn it quickly. You cannot store it. It's dangerous. So that's how they are doing that. Now, sponge is basically a type of hydroscopic gel, sort of say. What exactly is that? Nobody is specifying. They are saying it's proprietary. Everybody is working on it, but I could not find the exact detail, unfortunately. So this is what we are working on, direct air electrolysis. So there is this company that made this popular, that is Solhyd. I have no idea what the heck that name supposed to make sense, but that's what it is, and that's why this topic has become so popular at this point in time. Making complete modular unit for use. The idea is, same way you have solar panel right now that you can just buy. You don't think about it. You just buy solar panel, put it on your roof, go home, done. So the idea is the same. You put this panel, you get hydrogen, done. You do not figure out how to use supply distilled water and all that jazz. It's just like put the panel in and have it pipe for hydrogen. The end. It absorbs basically ambient basically humidity, and it spits out oxygen and gives you hydrogen, and all you have to do is figure out a place to put it, nothing else. So that's the aim, that this module, they're gonna put it a module and done. And this, inside this module, it's a normal solar panel, and below this module there are that basically direct air electrolyzers. So this puppies. Now it should be basically stackable and modulable, exactly how normal solar panels are. Basically how we stack up more solar panels to get more power, same should be doable with this. Exactly, basically it's just a thicker solar panel, nothing other than that. It's supposed to be just a thicker solar panel. However, be mindful, I looked through the website and the hydrogen pressure is tiny. It's basically 300 to 500 millibars. That's a lightweight puppy. Like, good luck trying to inflate a balloon with that. That's a very lightweight puppy. Now it is dependent on humidity, obviously it is dependent on that. And the company is making big bold claims about the fact that once it's done, of course this is a thing, it's gonna wear down, it's gonna erode, things is gonna happen, is that once it reaches end of life, it should be very easily recyclable. How exactly they have not specified, but it should be recyclable, hopefully. That's the company side. That's why this thing is so popular and blowing up recently at this point in time. When I'm making this video, I got a lot of requests for this. So let's look at some problems. The idea sounds good. It's just a solar farm, you build it and all you have is hydrogen output of it. That would be desirable for many industries. However, there are some problems, and this problem all comes back to the core thing. Devil is in the detail. And at this point in time, I'm old enough that I have seen MIT do some things that are like, dude, what the hell are you doing? And for example, like that plane that had no moving part, it's like, bro, it's creating ozone. Ozone is a toxin, it's pollutant, it's what we use to sterilize hospitals. It's not a good thing that you can just have a RC plane that's producing ozone. It's dangerous, and good God help you if you try to run jumbo jets on that. And that sort of information should be the first thing. Condition applied, it's a freaking dangerous to health, but that was detail was omitted. Did they knew it? Obviously they knew it, but the fact that they are omitting this sort of information, crucial information for accolades, for like attention, that's scary. And recently MIT, when they did that provider prop thing, is like, why the heck sound detail was missing in all the footage? Like, and I'm talking about people who studied in MIT, people who actually cleared MIT and all that. They're like, dude, what the hell MIT is doing? It's like, how the heck this sort of things are getting attention? And they do not have that MIT's caliber of data out of it, where it's like, no, this is exactly we did, this is how we did it, these are the data, these are the margin of error. That's the whole point of MIT, right? Thorough, precise, absolute detail, meaning you can go to court on that detail. And MITs are just like, no, it's just a video. It's like, dude, you're not a YouTuber. Heck, YouTubers have now more detail and data and all that jazz. It's like, what the hell is happening? And that's scary. So it's one of those things that whenever details are missing, I'm like, apply some brakes. And again, be mindful, that's exactly how solar roadway destroyed people. That's exactly how basically Nikola Motors destroyed public. That's exactly how many scam things happen, because details were missing. And once you put that detail into the context, then only it makes sense. So what is the detail about this puppy? Well, it would be very low yield. Can this work? This whole idea that having a panel which just pumps out hydrogen, can this work? Yes, let me be very clear. Physics will not stop it. Engineering will not stop it. Economics will say, what the hell are you doing? Or what are you smoking specifically? Because the yield would be very, very, very low. Like, low yield would be very low. Why? Because there is not enough water in the air. Like, you must have seen this sort of machine. Every few years somebody smokes weed and comes out with this, like, I can extract water out of the atmosphere. It's like, we know the only reason we don't do this sort of thing, like practically, is that if you try to do that, the energy cost would be so brutal. It would like just go to the ocean, put a pipe there, put a reverse osmosis plant out of there, get that distilled water to the people. That will be lower cost. That's why we never do this air water extraction. And be mindful, this sort of system, they have a paradox. It's like the place that is arid and dry, they don't have that much humidity. It will only work in a place that has high humidity for long terms. And here's the deal, what places have in common which has high humidity? It rains a lot. So you see the point, like, can this be machines be done? Yes, absolutely. We have done this. Like, I think the oldest machine that is known for doing this sort of thing is like 100 years old. And every few years somebody comes to like, water from air, water from air, water from air. But we know how this works. It's just like there is not enough humidity, especially in the place where you need it. It's not there. So outcome is very clear. If you go any place in the world, where be it where you are putting giant solar farm, would there be enough moisture unless it's next to a river? No. And not to mention, most rivers are drying. So yeah, good luck with that. There is not enough moisture. Flat out. It's not even a question. Flat out, it's not there. Maybe seasonal rainy season, but again, rainy season also has less solar power. So good luck with that. So there is not enough water in the air. Another aspect is there is not enough hydrogen in water. Now, this may sound odd to people who did not study chemistry with intent, and I don't blame you. I also did not. So it sounds like H2. What we want? H2. What water has H2O. So it's like heat the oxygen and we have hydrogen. Here's the deal. Many times units have to be used properly. For example, if somebody wants to sell you a BS, like hydrogen is awesome fuel, they're gonna give you, oh, hydrogen is 3 times more powerful. Here's deal. Get your sleeper and get ready to bitch slap them. Because here's deal. Yes, it is true. In terms of megajoule per kilogram, hydrogen has lot more energy than diesel. That's factually true. Here's the deal. Where is hydrogen in the periodic table? Is the first element, is the lightest element, meaning to carry basically 1 kilogram of hydrogen. Good luck. Good luck. Like, good luck trying to carry 1 kilogram of hydrogen. The tank would be gargantuan. Like, to give you an example, the Toyota Mariah tank, that is like carbon fiber, absolute top grade $1 billion industry research and development kind of tank that they built, which is idiotically expensive. That tank can only carry 5 kilograms at best. At best. Now, if you had that sort of tank made out of normal polythene, how much kilograms of diesel you can put in there? 70 to 100. That's the whole point. So kilogram can be used to trick you. So you go to liters, basically megajoule per liter when you are talking about a volume. So how do we figure this part out? Like how much basically hydrogen is there? Well, hydrogen, if you do it with any sort of electrolysis, is going to come out as a gaseous form. So it's very difficult to calculate. But mass is a good tool at this point in time. So what will happen if I give you 1 ton of water? Let's say you have this puppy, air to water. You get 1 ton of water out of it. Awesome. How much hydrogen is there in terms of mass, right? And you always talk about, like, megajoule per kilogram. Okay, how much tonnage you're gonna get? Basically, you have 1 ton in of water, pure distilled water. How much output you're gonna get? At best 10%. Realistically, mathematically, it's 11%, but good luck finding an electrolyzer that is that efficient, where it can extract 99.999%. You'll be lucky to get it even 10%. That's the reality of it. Why? Because again, people forgot the periodic table that hydrogen is the lightest element and oxygen is huge. It's huge. Like if you do H2O molecule in real life, it will, like, oxygen would be this big, tiny balls would be hydrogen. That's why. First, there is not enough water in air. And then even if you can collect the water, there is not enough hydrogen in that water. And again, I would urge you to do the mathematics yourself. I would urge you to do the mathematics of the mole mass yourself. So, and you need a lot of energy to compress that puppy. And I looked into that company website and all that. They have no data about, like, how the exactly you're gonna sell this unit. Whereas, like, if we're gonna give you the hydrogen, it's like, okay, what after that? The hydrogen can't be used directly. And again, the pressure that is coming out is very tiny. So you have to have a big tank that stores hydrogen. Once that reaches basic pressure, compressor has to turn on for a few minutes and then create a high pressure hydrogen that you can use to feed fuel cell stacks. Yeah, very tedious. And again, that will consume energy. Can it be done? Yeah, absolutely. It's just that the amount of energy that you are actually getting, useful energy, at the end of the day, the cyclic efficiency would be brutally wasteful. Then we come to another aspect which you could try. If I'm developing that company and it's like, what can I do? Well, here's the deal. I can use metal hydrides. This is the best way to store low pressure hydrogen and dump that hydrogen at high pressure without having any moving parts. You can just cool that puppy. It can just absorb hydrogen, and once you need it, you heat it up to, let's say, 50 degrees Celsius or 60 degrees Celsius, and voila, high pressure hydrogen output. It is done in industry also. It's a known thing, basically known technology. Then why don't we use it? It's just like very mass inefficient, meaning to store 10 kilogram of hydrogen, which is a lot, the tank weight would be 100 kilogram. It requires that kind of metal powder. So it's only used for submarines where they need giant amount of ballast weight. So at that point in time, it's like, shut up and take my money. It's free ballast, and it also acts like hydrogen storage. So that's one way, but be mindful that would be expensive for user. Why? Same reason lead acid battery is so expensive. It's heavy to ship. So, but it can be done. It's one way I can see where that low pressure of hydrogen can be used to slowly charge metal hydride banks, and when you need to discharge it, you just heat it up to 50-60 degrees Celsius, high pressure hydrogen for your fuel cell or whatever you need to. So their company's projection is, if I give you 1000 meters square, that is like a very big warehouse, you should get 2 to 4 ton hydrogen annually. Like, how much energy you're gonna get if you just had normal basic bitch solar farm? That's 285,000 kilowatt hour units. Basically, that much unit, 285,000 units of electricity per year. That's exponentially more compared to 2 to 4 tons of hydrogen. And that's just hydrogen. Be mindful. If you convert that hydrogen into electricity, you will lose a very large percentage of it, as large as 40% of it. So yeah, just using that energy directly is far more beneficial, far more cost effective, and it will not have the issues like, yeah, the panels always worked awesome in day one, but day two is like, yeah, humidity is starting to go down. Same things with these things. They always work, but only for first time. Once they start, oh, humidity is not something like it magically equalizes everywhere. That's why planet does not have one humidity value. It takes time to equalize. So, and the fact that they are saying they are using non-precious materials, that's awesome, that's good, but that's incomplete data, because here's the deal, using platinum metal has a fixed cost. But if you are using, let's say, something non-precious like silicon, so sand is basically non-precious, however it's still super duper expensive if you have to make ingots out of it. That's the whole point. So saying non-precious metal, it's like, what are you doing with it? Like, be clear, like, this is the plastic that we are using, this is the foam that we are using. If they are not clear, that again triggers a red alert. And no detail on exactly how they are using it or utilizing it always gives me that vibe, the same vibe that I got when solar roadway happened, the same vibe I got hydrogen truck happened from Tesla, not Tesla as in like Nikola, and same thing with all other hype techs. So it's like detail, the lack of detail from people who are engineers, technicians, and like top of their game, that's scary to me. So this was my presentation on solar hydrogen panels. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.